Welcome you all to the ninth and the last session of Special Theory of Relativity of 5th semester BSc Physics. I am Sunil M.H., Assistant Professor of Physics, Government First Grade College, Ranebennur. Here, in this session, we are going to discuss some problems on special theory of relativity which we were discussed earlier or in the last session. So the things which we are required before going to the session are the formulae. The first formula is the length contraction and time dilation formula. We know that the length contraction formula is given by L is equal to L naught into square root of 1 minus V square by C square, where L is an improper length and L naught is called as a proper length. And the time dilation formula T is equal to T naught by square root of 1 minus V square by C square. T naught is called the proper time and T is called the improper time. And the velocity addition formula, that is V is equal to U prime plus V divided by 1 plus U prime V by C square. Relativistic mass formula, M is equal to M naught by square root of 1 minus V square C square, and Einstein's mass energy relationship, E is equal to mc square. On these formulae, we are going to solve some problems in this session. Let us consider first problem. How fast would a rocket have to go relative to an observer for its length to be contracted to 99% of its length at rest? Here the given thing are the improper length, that is length for an observer who is on some S frame, that is L is equal to 99% of L naught, that is proper length. L naught is a length recorded by the observer in the frame of reference at rest with respect to the rod, which is equal to 99% can be written as 0.99 L naught. We need to calculate the value of V here. The formula which we use here is a length contraction formula. L is equal to L naught into square root of 1 minus V square by C square. Substituting the value of L as 0.99 L naught is equal to L naught into 1 minus V square, that we need to calculate, divided by the value of velocity of light, 3 into 10 power plus 8 meter per second, cancelling L naught and L naught in both the sides, then calculating V, we get 4.245 into 10 power plus 7 meter per second. The second problem is a particle with a proper lifetime of 1 microsecond moves through a laboratory at 2.7 into 10 power plus 8 meter per second. What is its lifetime as measured by the observer in the laboratory? What will be the distance traversed by it before disintegrating? We need to calculate two things here. One is the lifetime and the distance traversed by the particle. The given things are T naught, that is proper time 1 microsecond, and the velocity of the particle in the laboratory, that is 2.7 into 10 power plus 8 meter per second. We need to calculate T using the time dilation formula. T is equal to T naught by root of 1 minus V square by C square here, and substituting the value of T naught as 1 microsecond, V as 2.7 into 10 power plus 8. So solving these values, we get the value of T as 2.3 microseconds. Look at this, compare this. Here it is 1 microsecond, here it is 2.3 microsecond. So this shows that time has delayed. The second thing is the average distance moved by the particle before its disintegration, that is the distance is equal to velocity into time, V into T. Substitute the value of V here from here, 2.7 into 10 power plus 8 meter per second, into the value of T from here, 2.3 microsecond. Solving this, we get somewhere, do it yourself. And the third problem, an electron is moving with a speed of 0.85 c. C is the velocity of light in a direction opposite to that of moving photon. Calculate the relative velocity of the photon with respect to the electron. So here it is given the values of V, that is value of v is nothing but a speed of electron, that is 0.85 c. Here given u prime, that is the velocity of the photon, u prime is equal to c, and we need to calculate u. From velocity addition formula we have u is equal to u prime plus v by 1 plus u prime v by c square. So substituting the value of v and u here, finally we get the value of c. So the velocity relative to the photon with respect to the electron, velocity of the photon with respect to the electron is always be c, because the velocity of the photon, that means that the light particle, never changes, it always remains constant, it is c. Move on to the problem 4. At what speed is the particle moving if the mass is equal to 3 times of the rest mass? It is given that or mentioned that m, mass of the particle, is 3 times of rest mass when it is moving with some velocity. We need to calculate that velocity. From the equation, relativistic mass m is equal to m naught by square root of 1 minus v square by c square. Substituting the value m as 3 m naught and cancelling m naught on right hand side and left hand side. Substituting the value for c, we can calculate the value of v as 0.94 times of velocity of light. The problem 5, calculate the rest energy. Rest means rest mass energy of an electron in joules and in electron volt. As we know, m naught is the rest mass energy of the electron. Its constant is 9.11 into 10 power minus 31 kg, and c is the velocity of light, 3 into 10 power plus 8 meter per second. As well known equation, E is equal to m naught c square. Substitute the value of m naught from here and value of c from here, multiply these two things, we get 8.2 into 10 power minus 14 joules. This is in joules. When we divide this by 1 electron volt value, that is 1.6 into 10 power minus 19, the value of 1 electron volt, we get 0.51 million electron volt. This is the rest mass energy of electron in electron volts, and 8.2 into 10 power minus 14 is the rest mass energy of electron in terms of joules. Taking sixth problem, the total energy of a particle is exactly twice of its rest mass energy. Calculate its speed. So we need to calculate the speed here. The given thing is that the energy of the, means moving energy, or the total energy of the particle, that is mc square, is equal to twice of the rest mass energy, that is 2 m naught c square. We need to calculate the speed of the particle. So using relativistic mass equation, that is m naught by root of 1 minus v square by c square is equal to 2 m naught. Here substituting the value m as m naught by root of 1 minus v square by c square. Cancelling m naught and substituting and c square also, we get the value of this root of 1 minus v square by c square as 1 by 2. Squaring on both sides, we get right hand side as 1 by 4 and left hand side we get 1 minus v square by c square. Substituting the value of c as 3 into 10 power plus 8 meter per second, we can calculate the value of v, which will be given v is equal to root of 3 by 2 into c. So substituting for c, that is 3 into 10 power plus 8 meter per second, we get the final value, that is the velocity or the speed of the particle is 2.598 into 10 power plus 8 meter per second. Take 7 problem. A particle of rest mass m naught is moving with the velocity 0.9 c. Calculate its relativistic mass and kinetic energy. So rest mass energy m naught is given, the velocity of the particle 0.9 c. So we need to calculate its relativistic mass, which is given by the equation m is equal to m naught by root of 1 minus v square by c square. We substitute the value for V as 0.9 c whole square, c square gets cancelled out, and solving this equation, this value, we get 2.3 terms of rest mass m naught. Then its kinetic energy is expressed as m c square minus m naught c square, where c square is common, m is a relativistic mass and m naught is a rest mass. So m we have found that is equal to 2.3 m naught minus m naught. Taking m naught as common, 2.3 minus 1 is 1.3 m naught c square. This is the value of kinetic energy. The problem it is that a particle of rest mass m naught moves with the speed c by root 2. C is the velocity of light. Calculate its mass and momentum. Given the velocity of the particle c by root 2, which we can say that 0.7 times of the velocity of light c. The mass from relativistic mass equation, m is equal to m naught by square root of 1 minus v square. Substituting the value of v as 0.7 c and solving this denominator, we get 1.4 times of the rest mass energy, rest mass m naught. And we need momentum. Momentum is nothing but product of mass and velocity. Here we have found m is equal to 1.4 m naught and velocity v, it is given 0.7 c. So multiplying these two things, we get 0.98 m naught c. 0.98 is approximately equal to 1, so we can write this as 1 m naught c or m naught c. Look at the ninth problem. A clock in a spaceship emits signals at intervals of 1 second as observed by an astronaut in the spaceship. If the spaceship travels with a speed of 3 into 10 power plus 7 meter per second, what is the interval between the successive signals as seen by an observer at the control center at the ground? The given things are t naught, that is in proper time, is equal to 1 second. The velocity or the speed of the spaceship is given 3 into 10 power plus 7 meter per second. We need to calculate the time recorded or measured by the observer in the ground using time dilation equation. T is equal to t naught by root of 1 minus v square by c square, and substituting the value of t naught and v, we get the time recorded by the observer as 1.005 second. Look at here, the time recorded by the person on the ground and the time recorded by the person in the spaceship are different. This time that is t is somewhat greater than t naught. This is called time dilation. Move on to the 10th problem. Calculate the kinetic energy of an electron moving with the velocity of 0.98 times of the velocity of light in the laboratory system. It is given that m naught, that is the rest mass value of electron is 9.11 into 10 power minus 31, and the velocity is given 0.98 times of c. We can find m by using the relation m is equal to m naught by root of 1 minus v square by c square. Substituting the value of v as 0.98 c and m naught as 9.11 into 10 power minus 31. The value of m, that is a relativistic mass, is as 5.02 m naught. So this is the relativistic mass value. And here we have kinetic energy equation. The kinetic energy is a sum of m c square minus m naught c square. So we can write c square as common, m minus m naught, where m is we have a value for m 5.02 m naught minus m naught. So m naught, taking m naught as common, 5.02 minus 1 become 4.02 m naught c square. This is the kinetic energy value of the electron. Substituting the value of m naught and c square here, we get the kinetic energy of the electron as 3.296 into 10 power minus 13 joules. If you want to calculate the value in electron volts, just divide it by 1.6 into 10 power minus 19. Then we get in the kinetic energy in terms of the electron volt. So the things which we are studied in this session are basic concept definitions and fundamentals of relativity, familiarity of all formulae discussed in this chapter which were used to solve some problems here, problems on all the topics of relativity. So with this I put an end to this session and the course of 5th semester relativity. So you can go through these books for further references. So thank you all for your kind attention throughout the sessions. Thank you all.